All right, good morning. You are coming out of a break. And not only that, we're totally switching gears. So welcome to your backend or your full stack journey. What do I mean by full stack? Well, you already know how to build front ends. Of course, we're not expert. Nobody is an expert at that right away, right? So we just need to practice a little more. But we know the basics of how to build the front end. So what we're going to do now is talk about what happens on the other side of that. Whenever you do axios.get or axios.put, that reaches out to some server somewhere, and something happens, and then you got a response back. Well, we'll see. We're going to peek behind the curtain now and see what happens on that other side of that Axios call that you're making, right? So here's how it's going to go. So this is 5 weeks, including the project week. The first 4 weeks, though, let me make sure that everyone's muted. And right. The first week, we're going to do a quick, gentle, and slow introduction to what Node.js is and what is this Express thing. And then from there, we're going to go into, and of course, there are different parts in there. We're going to go into data persistence. So how do I add a database support to my application? I'm going to introduce relational databases and what does that relational means. And then we're going to go into securing your API using authentication, you know, whenever you do login, log out, register, and all that. And then how do we test this thing? And in the testing week, we're going to do a quick introduction to testing. We're going to demystify some terms. We'll see very briefly, we'll see React testing, and very briefly, we'll see also server testing. It's not a complete testing course, but it's at least the basics of it so that you have an idea of how testing works, and then you could go deeper from there. So I'm getting a message that says that Zoom changed its software, and I want to hide the participants window, but I can't anymore. Really? Huh. I don't know. I'm not running into this issue, maybe because I'm just sharing my screen. Interesting. Okay, so apparently there is a view panel at the top. Someone said, let's see what happens if I click to. So the view options, if you're full screen, there's a view at the top. I'm just reading the stuff that Lauren is typing on Slack. Hopefully, even if you can get it out of the way, at least I hope that you could kind of, I don't know, tuck it to the side as much as you can so that it doesn't get in the view. Maybe something like this, I don't know. Oh, got it. Cool. So let's continue on. So that's the idea, right? We talk about how to build the API, then how to add databases, how to secure it, and then how to test it. And that would be your backend journey. Of course, we're going to go slow in the beginning. And the first thing we want to take a look at is what's on Training Kit. Well, we're going to see today, as the first day, what is Node, and a very gentle, more like a high-level context view, right? So what is this thing? What does it mean to be on the other side? How does it mean to be on the server? So we're going to go through that and see a little bit of the theory. Of course, you had some videos already made by Ryan Hamlin there that goes to this same concept. So we're going to go faster, right? I want to do this the first hour. Now, the second hour, though, I'm going to ask you to please follow along with me as we start building small project that will continue to work on the class. We're going to work to that project through the whole week. And you're going to have a couple of projects that you're going to work for the afternoon. Those are separate, right? The one that we're going to clone today and work in the class is the one that we build together. But then you have an assignment that you're supposed to build by yourself in the afternoon. So let's get the theory out of the way right after a quick pause for questions. Any questions? In case you don't cover this in lecture, I noticed on the GitHub project, the package.json points to server.js, but we only have the file index.js. Ah, that means that yours truly made a mistake. Yeah, we have this index.js, but then package.json is wrong. Should be pointing to index.js. So let's change this. And this is what I'll do. Index.js, point this to index.js. Updates .json to point to index.js. And commit that. Thank you, sir. That was all me. I made a mistake. Thank you. Yeah, so I just made a commit and pushed it right away. Once that. Cool. Good eye. All right. Any more questions? Right. So Node.js, what is this? Well, it's a way for you to use JavaScript outside of the browser. Again, for people on the video, there are some videos here in the material that students went through before the class today, so they already have a deeper explanation on all that. We're just going to touch up on some of them to get any questions that you may still have. Of course, there's more to Node. If you're going to do Node in the documentation, this is just the latest version that they have on the website. You'll see that there is a lot in there. Encryption, you know, working with the console. For us, though, we're going to concentrate on Node.js as a way to run JavaScript outside of the browser. Okay? That's what we care. It's not an accurate definition what Node is, but this is what we care about when building our API. We're not going to use Node to build games or to build console applications. Like, for instance, Slack is built using Node. It's running on Node. Visual Studio Code, which is the editor that I use, also uses web technologies. It's being written in JavaScript, and it runs on Node. Okay? We're not going to build anything like that. We're going to concentrate on building APIs that work with JSON data. You have already done that from React, sending JSON and getting JSON back. You're just going to build the server that handles that on the other side. There are some links on Training Kit that you follow. Of course, JSON. There's some advantages. Ryan explains those on the videos, but the idea is you have JavaScript now on the server, same programming language. So you no longer have to switch. Like, you're thinking in JavaScript when you're building your client, and then you switch to working on the server, and it's some other language that the syntax might be totally different. Maybe that language is synchronous by nature instead of asynchronous like JavaScript. So now you started thinking about blocking I/O and the problems that come with that. Maybe that language is multi-threaded, meaning that you could run in parallel, different things at the same time, but that means that you have to handle now communication between those different threads. In JavaScript, it's single-threaded, so you don't have that problem. Again, advantages and disadvantages of using Node.js for building an API. All of this is in the context of building an API, a RESTful API that handles JSON data. The NPM repository is one of the advantages. I want you to notice something on this list, though. Let me make this a little bigger just in case. The advantages and the disadvantages are the same. Kind of strange. But there's a reason for that, right? Your greatest strength may lie your greatest weakness. So JavaScript on the server, the same programming language, but what's the problem with that? Well, some languages are better suited for other things. If you're using a lot of heavy data, CPU-intensive data manipulation, maybe you want to use Python instead, okay? But if all you know is JavaScript and you are forced to work with JavaScript on the server, you're going to be using JavaScript for something that is probably not the best solution for. Another advantage, single-threaded. Yeah, excellent. You don't have to deal with multiple threads. But that means that if you have a processor that can handle, 16 threads at the same time, you're not taking advantage of that because your language does not support it. It's asynchronous. This is excellent because since it is single-threaded, cannot run things in parallel, being asynchronous means that it doesn't have to wait for long processes. You just continue on and, be able to handle a lot more requests on the server, even though you're only using one processor or one core of a processor. So asynchronous by nature, because of the language, JavaScript, is how a Node server can handle a lot more requests than, let's say, something built in Ruby on Rails. Because it is asynchronous. It doesn't have to wait for expensive operations like accessing a database or accessing another API with a network or even reading files. It could just say, go do that, and then when you come back, let me know. But meanwhile, I'm going to be taking care of this other request. Okay? Also, the NPM repository means hundreds of thousands of snippets of code that will add functionality to your application that you don't have to know about. Like, for instance, you want to use Google Maps. Well, you could probably do that by hand, pure JavaScript, but then again, why not use libraries provided by Google for that? And they're there. We have used NPM for React. We say, hey, we don't want to be handling the DOM by hand and synchronizing all of those nodes together. So we're going to bring in a library using NPM. But then again, drawbacks. Well, way too many packages that do the same thing makes it harder to choose one. Okay? What about, look at this. They may introduce vulnerabilities into our code. Well, what if one of those libraries is malicious? What if one of those libraries has a security problem? It's not malicious, but maybe there is some vulnerability on the operating system that they could get access to through that library, even if the library author doesn't know about it. So there's always a risk when you bring in somebody else's code that you can bring bugs and vulnerabilities with that code, along with the functionality that you wanted. This gets better and better as we learn more, but still there's a risk. Okay? And there are, as people are saying on Slack, there are famous examples of that, of problems with vulnerabilities on NPM packages. So, questions about Node. Again, if you go in here, you'll know that there's a lot more than just, originally Node was created as a way to write network applications using JavaScript. Turns out that web applications are applications that run over a network. So immediately we started using that to build servers for web applications. Okay? This is one thing we're not going to do in class, though. We're not going to bring in and just build a raw Node server. The code is there. The instructions are there. You could go through that on your own if you want to practice that. Because in reality, you're not doing that a lot, right? So we're going to move to this, Express. And I say Express for your API is like React for your web application. It's just a way for you to have a package that is going to give you a nicer, cleaner API, and that is going to take care of the low-level details involved in dealing with networks for you. If you went into NPM, a very good resource for web developers, and look at an HTTP, remember that HTTP thing that you see there, HTTP or HTTPS? This is just a protocol, a networking protocol, right? What is a protocol? Well, a set of guidelines or constraints that you have to follow in order to obey the protocol, to be able to use it, right? So in the case of networks, that means all of the rules of how messages are transported over network are written in that protocol. We happen to use HTTP. This is the protocol that is most widely used for web applications and websites on the web, okay? So when you say Axios.post and you send some information to a server, and I'm saying Axios because it's the library that you could be using fetch, right? The native fetch from JavaScript now. But any library where you're doing a post to a server, in your React applications, you're sending what is called a message. And an HTTP message has a structure, has 4 parts. We mostly care about 2 that happen to be optional, by the way. Let me make this a little bigger. So this is basically the structure, the anatomy of an HTTP message that you send from a client to the server and back. We care about this, point number 2, which is an optional HTTP headers, and number 4, which is the optional HTTP body. You have used that, even if you don't remember. Now, here's the thing. Axios is going to set a lot of those headers for you. And if you think of the body of the header, think of them as just simple JavaScript objects. They have properties that are sent, and we don't know this. But if I want to open this, I mean, we don't notice this as users. We don't need to know about it, actually. But if we go into the network and I refresh on this page, look at all the messages and all the stuff that's there. If we went into one of those, let me see if we can make this a little larger, easier to see. And we take, let me see, let's click on this one. And you look at this tab right here that says headers. There's a response, there's a preview, but here's the headers. You have some general headers, the response header, but also you have the request headers, right? So as I said, you could think of this as a JavaScript object that has keys with a value. So the catch control would be the key, and then this information right here, which is a string of this text, would be the value, okay? This is happening without us knowing, right? This is doing a method called get, an HTTP method get. This is getting a status code of 200. This is where we're hitting this. This is the IP address and the port 443, meaning this is secured, right? And then we have some of the response headers, right? The stuff that we get from the server with a lot of information in there. And then this is the headers that our browser sent automatically for us. All of those are sent by this application, by this browser, to the server, to the MDN, the developer Mozilla.org server. Right? So imagine whoever's building this server on the other side, to answer to that, has to know how to read all of these headers, no, not this, the request, all of these headers, and know what to do with those. There are a lot of headers, okay? And there's a lot more to building a server than just headers and the body, okay? You need to be able to parse the body, read information from the body. So what do? Well, we bring in a library. That library is called Express. And it's got nice advantages. You could build different applications with it. The ones that we care about, that we're calling your attention to, it's really simple, it's unopinionated, it is extensible, really lightweight. It's very clean. The API is very intuitive, right? And of course, when you're writing a web application, you have to deal with all of those networking things. This library is going to abstract away a lot of common tasks that we have to deal with. They're done by Express. So there's a comment there, says, can I think of headers basically like in a paragraph, but just in an object format, whereas body is the actual code? You can think of it that way. Yeah, for sure. The way that I see it, though, is I see the headers as a way to kind of agree with the server on some things, like, hey, this is a format that I want. Hey, this is, by the way, this is my authentication information. Another way of me to send information to the server, but with a lot more meaning as a way to communicate with the server. And then I think of the body as a data holder, like a bag where I put all my data, the data that I want to send to the server. That's how I see it. But you could definitely think of it that way, as a document. Some of the main features, and this is important, right? You're going to see me separate routing from routers, just because I want to call your attention to this application modularity, right? So the main features, if I ever ask you that, what are the core features of Express that we always want to keep in mind? The first one for sure is middleware. And then middleware, we'll learn about middleware tomorrow, so don't worry about it now. But what's important is that middleware is a way for you to extend the framework. See how we said that it's lightweight and extensible? This is how we do that, through middleware. And by the way, here's a secret, don't tell anybody, but almost everything in Express is middleware. They kind of built a middleware framework, and then they starting adding to it other things as middleware. It's like if you look at React and you say something like input, you're not actually using the input from the input HTML tag. It is lowercase and it looks the same. But believe it or not, it happens to be a React component provided by the React team. So when you say H1 or you say div, that's not the browser div. It's a div component provided by the React team. It's the same thing with Express. So React built a component framework, where for you to build components, and everything they give you is treated as a component. Here, everything is middleware. Very, very important feature of Express. And then you have routing and routers, right? Which is something that takes advantage of the routing. You can think of routing as, how do I know what I want to do with a particular piece of information on my server? For instance, let's say that we're writing something about products. How does the server know that what I'm trying to do is create a product? Well, the way that you communicate that is through two things. What URL am I hitting, and what HTTP method am I using? You might remember, and again, we saw the anatomy of the messages, but you might remember there are different HTTP methods, right? You have this get, the head, the post, the put. We don't really deal with that. This is normally done by our libraries. But you might remember the delete, the put, the post, and what we call the CRUD operations, right? So the post method is used to submit an entity. We're going to give this a different name as we talk about this. But think of it as the same. If I'm dealing with products, that means submit a product to the specified resource, often causing a change in state or side effects on the server. By side effect, I mean I want to create one. Same thing with the put. I want to update one. And after doing a get, I'm expecting that my server is going to send me some data. So it should only retrieve data, right? There are some rules in this. Remember, protocol, some guidelines, some rules that we accept on both ends to have effective communication. This is part of the HTTP standard set of rules for that protocol, right? So when hitting that API, of course, we're going to be building something called a RESTful API. Now, we'll talk about REST in a minute. But the idea here is routing is going to let us decide which piece of code we execute on the server based on the URL and the HTTP method used. Okay? Then we have this application modularity that we can get. Same way that you don't build a React application on one single file, you break it out in components. You build your application on the server the same way. You break it up into different areas. The way that we approach this is we build what's called routers. So think of a router as a sub-application, like a mini, tiny application that only deals with a portion of your big app. The difference between a regular Express application and a router is that the router needs to live inside of a main application. It's like all of your custom components, they live inside of a main, let's say that you call it app component, right? And then everything else is inside that app component. It's the same concept. You have an Express application outside, and you can break the rest into small sub-applications using what is called a router with uppercase R. And of course, we have a lot of convenience helpers. This is what makes the API so beautiful. They say, hey, what if someone wants to see the IP address of the client connecting to the server? Well, they give you a property on an object called request that has a lot of information about the request and some methods to operate on that request. And what do I mean by a request? Well, a request is something that comes from the client in the form of an HTTP message. That means that request is just an object that has, of course, headers and also has a body, potentially, right? Maybe empty, but there may be data in there. But also the request has other information. Why? Because if you go look at the anatomy of a URL is more than just google.com or mozilla.org. There are other parts to it, okay? You have, as you can see right here, this is the protocol that we're using, maybe HTTP, maybe HTTPS. You have the domain name, this is the host name. Then you have a potential port. You have seen this because if you run your React application, it says localhost colon 3000. That 3000 is the port number, and we'll talk about what a port is later on. And then you have this slash users, a slash whatever that you handle with the routing, right? You use the React router for that. Well, that is the path. But then after that, you could have other stuff. Like, for instance, you could have this section right here that has a question mark and key value pairs separated by an ampersand. These are parameters. This is known as the query string. And these are just parameters of that query string. But you can also have this hash something at the end that we call this an anchor. It's also called a fragment. Well, the real name is a fragment. We just happen to call it an anchor. So and a complete URL can have all of those parts or a portion of those, okay? Another good article, I'm going to drop this in there just in case. I don't think it's on Training Kit yet. But this is a kind of an easy way to go to that same content, but in a more colorful way, I guess, okay? He says, this is how everything is broken down. Google.co.uq is domain name, and then this is a subdomain where you can have blog.lambda. Students.lambdaschool.com, right? This would be the subdomain. So this is a nice article. Go through it if you have the time, or just bookmark it for later. I'm going to start closing all of this, so we don't need it for now. And of course, Express is going to help us with that. Okay. Questions so far? I promise this is the most boring lecture that you're going to have when you have to see me talk about this stuff. Later, we're just going to be writing more code. One more thing, and then we go back into this section and start writing our first server together, okay? First, I want to ask you if you could please start by cloning this to a folder on your computer. So just clone it. It says there on Slack. This is the Express Mini that we're going to use this week. Clone that. I need to do the same, actually, and then we'll work on that as we go. So one more thing. What is this REST? Because I said we're going to build RESTful API. Doesn't mean that I'm tired and I want to go and take a break. No, this is actually an acronym for, is it still called an acronym? Yeah, it is, because we're saying REST instead of REST. That would be initialisms. I don't know. So this means representational state transfer. And it's a set of principles. So it's not rules. It's not something you have to do. It's just a set of kind of recommendations. It's not a standard. Look at it in bold right there. Provided by someone called Roy Fielding on a this is dissertation that he did in 1999. But the idea here is he said, well, if you build applications this way, they're going to be more scalable and they're ideal for distributed software. Web applications happen to be a way of, distributed software, just the type of software that is accessed, different parts are in different places over a network, on the network, instead of all being packaged into one monolithic thing that's running on one place only. For instance, if you open Microsoft Office, Office is running on your computer, and if you want to run it on another computer, you have to install it there, right? But in the case of the Office Online, though, it's a distributed application, and it could have a piece of the application is in one server and the other piece is in another server. The database may be in even another server. So that's what it means by distributed. All of the pieces of the application are not in one single place, but they are in different pieces broken down in that could live in different servers, even in different places all over the world. okay? So REST has a lot to it. There is a link here for the original documentation introducing this thing. It's more than the chapter that I linked to there, the whole thing, but we care about this one, right? Chapter 5 of this whole document. And the idea here is he defines a set of, I think I'm looking at the wrong channel on my Slack though. Let's see. Here, good. So the idea here is he's got a set of constraints. And he said, in order for you to say that your application is RESTful, you should implement all of these constraints. The application should pass. If we check for those constraints, it should pass all of those constraints. So the first one is client server. We don't have to talk about this. Client server architecture is what we do on the web. We have a client connects to a server, okay? Stateless, turns out that we get this for free because we're using HTTP. HTTP happens to be a stateless protocol. What stateless means is there is no memory, there is no shared state between the client and the server. So normally the way that it works is if you connect to a server and you make a request, the server is going to answer that request and it's done. When you go back and connect to the same server, the server doesn't know it's coming from the same client. We have found ways around this, okay? We have cookies, we have tokens, we have different ways of faking that state, but it's not real, okay? The protocol itself has no built-in way to share state between the client and the server. So this is free when you're using the web. Catchable. Well, HTTP also defines a way for you to catch stuff. And the idea here is if there's an operation on data that always returns the same data, why are we going to have the server recalculate that operation all the time? No, we could just save that somewhere. I know that you probably did exercises on what is called memoization, right? Where instead of you running a really expensive operation on a function or something, you just keep the result of that operation somewhere that you can quickly access, maybe an object, because it's really, really fast. Turns out that we have built-in ways of doing this on the web too. So the idea here is you can run into this. Idempotent means it's like a pure function, basically giving it the same. When you do the same call to the same place with the same arguments, you always get the same result back. That's what it means, okay? Like for instance, a post is not. Because every time you do a post, you're creating side effects because you're changing the state on the server. You're creating a new thing. But if you do a get, and I say, hey, get me, if you go to GitHub and say, get me the repositories for a particular user, every time you do that get, unless the data changed on the server, every time you do the get to the same server that has the same data, you always get the same response. So the get, the put, the delete, all of those should be idempotent. You always should get the same results. So if you delete something and then you try to delete it again, you're going to get the same response. The thing is not there because it was deleted the first time around. So if you do a put to update a record, changing the name, the record that you get back should have that new name. So if you call it again and again and again and again, you're still getting the same results back. Always the change. The difference with the post though is that every time you do that, you get something different back because it's a brand new record. It's like creating a new object all the time. Even if it's got the same data inside, it's a different object because it's on a different location in memory. If you compare them to see if they're the same with triple equals, JavaScript is going to tell you no, they're not. Okay? I'm mixing JavaScript just to give you context of what this means in terms of an API. Okay? A layer system. Well, we kind of get that on the web, even if we don't know. We get the illusion that when we say google.com, we're hitting from our client, we're connecting directly to a Google server where google.com is. That may not be the case. Normally or often, that is not the case. The way that the network systems work is you can have a set of layers inside. A good example of that is a DNS server. A DNS server translate for what you call lambdaschool.com into an actual IP address. And that IP address points to what the server is. The piece of software in charge of translating something that we can remember into an actual set of numbers is called a DNS, a domain name server. So normally when you're hitting a web, at least first you're hitting a DNS server. Not to mention that you go through your ISP. I live in Utah. I am in Provo. I go through Google Fiber. So even if I'm going to lambdaschool.com first, I'm hitting the Google Fiber servers, a DNS server, probably some caching server somewhere, some logging server somewhere, some load balancer, which is a set of servers that will decide, hey, there may be 5 servers that have the lambdaschool.com domain. Because maybe you have Amazon.com and one single server cannot handle all the traffic. So you may have thousands of servers all over the world. So that load balancer decides, okay, all of my team of servers, which is the one that has the more resources to answer this faster, and just route information to a server, to different servers. So all of that is built into the web already. So we cannot get that for free, that constraint. Code on demand, this is one that I was really, really scared when I saw it, right? Where it says that, you know, the API is not only going to return the data, but it's also going to give you some code and say, hey, go and execute that code. And when I saw that, I was like, you're crazy. I will never build a system that way. How can I build a system, or how can I have a client that it's okay receiving executable code and it's just going to blindly run it on my computer? This is how viruses get transmitted, right? Would you ever do that? Would you ever use an application where some servers just send you new code for you to run? Would you do that ever? Questions for you on Slack. Yeah, that's exactly what I say. I would never, ever do that. That doesn't really sound like a good idea. Hey, I have another question. It says, will we be going over Rails Django later? No, we're not going to talk Rails, but on the CS portion, they do deal with Python, and I think they use Django. So you will see Django, not Rails. So as I was like, that sounds like a trick question. Well, it is, because this runs like a really bad idea. But then you go and say, all right, so when I hit any website that has a React application in it, what am I sending back to the client? HTML, CSS, and JavaScript. And what is the browser going to do with that JavaScript code? It is running in a sandbox, but what if it is something built with like a game that is running something like the .NET framework or Django running on Python? Even though it's running on a sandbox, what we are actually doing is we are saying, I'm going to send you code that you can run and execute. You don't need to some address here on your browser or some address that you hit from your application. So normally, if you think of your API as a function that you can potentially pass some data and it's going to give you back a response, right? If you think of it that way, the way that you use that function is you bring it into your application and you call it by its name. Let's say that it's called add or multiply two numbers, right? Multiply two numbers, then you pass two numbers and you get something back. In this case, though, you don't get the JavaScript code or the function name so that you could call it directly. The only way that you can communicate with that server is via that URL. So that URL goes in place of that function name that you can just execute. So you're basically calling that URL from your code. And you have been doing this. You have been saying, hey, go and do a get to this URL using Axios, for instance. That's what we mean by interfaces. Each resource, products, users, items, sales, orders, should be accessible through a single URL. All the code that we have behind this training kit is accessed through learn.lambdaschool.com, and then the rest is just other things like the pathing, right, for the routes. And in this case, I have module, and then passing this ID here. This is a parameter that I'm passing the ID to this particular resource. Let's call it that. Again, you don't need to be an expert on this. It's just know that when we say RESTful, we're talking about a system that kind of follows these guidelines, okay? Some things to keep in mind when you're designing RESTful APIs, because first we're gonna give you, and this is probably a good moment to introduce this. First, when you start out, I'm gonna talk a little bit about your journey through Lambda here. You have, through the web portion, 15 weeks, okay? The first 5 weeks, you can think of you as a newly born baby, okay? You can't do anything by yourself. We have to feed you every little bit. We have to bathe you. We have to clean you up. We do everything for you because you are from a newborn baby. So Josh is like your mother, right? You fall into Josh's arms, and he's gonna take care of you all the way through your infancy, right? Newborn, a toddler, and then a young adult, as they call him now. But the idea is you're a kid, you're a little kid. So we're gonna give you a lot of guidance there. And then you go into React, you're like a teenager there. I think of it as a teenager. You could do stuff now, and you're really smart, but sometimes you still make the wrong decision. So we're still giving you a lot more guidance, okay? So we're gonna give you more descriptions and stuff. And then you come into my section, and I think of you as an adult now. Albeit a young adult, but you already know how to make it up and make it happen. So what you'll notice is, if you go look at this, the lab for today, I'm gonna give you exactly the URL for the endpoints, exactly the method that you should be using. And I'm gonna tell you what it does. And then I'm gonna give you some specifications for that endpoint. So when you're doing a post, I'm gonna tell you, hey, what happens if the title is missing and the content is not there? Well, you're gonna cancel the request. You're gonna respond with this code, this particular code right here. And then you're gonna return a JSON response that has this structure. And I'm gonna give you that for all of the endpoints. Of course, as you learn more, I'm gonna be giving you less. So it is possible that on a next week, when I tell you, hey, I want you to build a post endpoint, I may end up just giving you this. And expect that you will be mature enough to know, hey, this is expecting a title and a contents. I should probably validate for that. And I expect that you're gonna come up with, hey, if this is wrong, I'm gonna return this as status code. But if something was created, I don't have to tell you anymore next week that you should return it to a 1. I expect that you're gonna learn over this week. So instead of giving you all of this detail just for building 5 or 6 endpoints, I probably just end up giving you this. But maybe on week 3, you're not gonna get not even this list. I'm just gonna tell you, hey, you're gonna build an API that's gonna handle, I don't know, users. So I expect that you know that if you wanna create those users, you're gonna come up with the URL and you know that it's gonna be a post. I don't have to tell you that anymore. So you will see me giving you less and less information as we go along. By the time you get to the CS portion of it though, they maybe even give you less information. Maybe they're gonna ask you, maybe they're gonna throw you into the deep end of the pool and tell you, hey, I want you to build this, doing this technology. By the way, you're gonna have to learn it and then build it. So maybe you're making it up, learning it, and making it happen. Okay. So it's okay if you hate me as I give you less and less handholding. It's okay. And I think this is a wrong term when I say handholding. I say descriptive instructions. I'm going to give you less and less of on that so that you have more. And you can look at it those in different ways, right? Like everything in life, right? It's either this is a constraint now because I'm not getting the full instructions, or you could say, hey, I have more flexibility now. So maybe I don't want to return a 201. Maybe my API decides that maybe I don't want to return something like this. Maybe I want this call message only, or maybe just error. So think of it as you're getting free to be able to build it the way that you want it, okay? And if you feel you still don't have the tools, I want to know about it. But then your PMs is going to talk to you about that today, probably, right? So back here. That's RESTful. And then after that, we're going to go into code after a 5-minute break. So questions before we go into a quick break. Kai wants Josh. So the difference between URI and URL. URI is identifier because, let me show you this in the beginning. Maybe I didn't say that loud enough, right? So here it is. So we want you to think of everything as a resource. So instead of being a locator only, we want to think of it as an identifier because of this idea of uniform interfaces, right? When we say, we say each resource should be accessible to a single URL. If you're referring to, let's say, a particular user on GitHub, that user URL should be unique. And it should be unique for that particular user. So we say that it identifies that resource in a unique manner. So a unique URI, right? While URL is normally what we used to, and I use them both interchangeably. I don't know if it's like a real technology difference between them. Like a locator is how do I find something on the web? But in this case, I want to think of it as how do I identify a particular resource when you're building an API the way that we are? So it's not about locating a page, but identifying a resource. So resource identifier. But I do make the mistake of saying URL a lot. Okay, that's it. All right, so let's take a 5-minute break, and then we're gonna come back. And please be ready because we're gonna work on this Node Express Mini. So if you haven't cloned that, just clone it while you take the break. See you in 5. Font size check. Can we read this? And we're back. So we can get rid of this. We want to talk about the project for this afternoon at the end of the class. The last 5 minutes, we're just going to go through this. You don't understand it yet. So here's the project. I took the liberty of cloning it, have it on my computer, opened it on my editor. I haven't done anything with it yet. It's just cloned and open on the editor. So here it is. There are some files in here that are provided. You're not gonna care about those yet. You start caring about more and more as we go through the backend week. But just know that we have a package.json. We're bringing in a couple of dependencies there. We're gonna learn more about how package.json work as we go through the class. There's no one day that we just talk about the package.json. But know that we have this server thing inside of scripts. Have you ever wondered why is that you go into any terminal? Let's just put this stuff on the right there. Okay. Why is it that you could say, after you create a React application, you could say yarn start or yarn, well, you only don't start for now. Yarn start. And that just runs some code and application shows up in the browser. Well, what this is actually doing is this start is something that exists inside of the package.json at the root of the file, of where you are running this on the terminal. That happens to be called start. So if I could say lift off, like so, I could just say yarn or npm run, right? It could be with npm run lift off. So npm run or yarn is just a way for you to run a script that you have defined inside of package.json. Does that make sense? The one that you downloaded is probably called server, I think it is. Let me see, I have it. Yeah, it's called server. So instead of doing yarn start, we're gonna do yarn server instead, because that's the name right here. Of course, if we run that, it's gonna fail because we have nothing in there yet. And we have these dependencies. So how do we get dependencies installed? We need to run yarn or npm install, right? So I'm gonna run yarn. Node modules folder should show up here. There it goes. Now it's downloading a lot of packages for me. And I want to give you a quick rundown of the project because it's going to be similar to what you're going to work on this afternoon. So let's do a really quick rundown of this. This is asking that we use Node and Express to build an API that performs CRUD, create, read, data, and delete or destroy, depending on who you ask, operations on users. For the afternoon, though, you're going to be working with posts instead of users, right? Change the names, but the same similar idea. You know how to do this already. Run yarn or npm install. You know how to do that. The only difference is we have this little file called db.js that has some functions in it that we can use. So the same way that you bring in Axios into a project, you're going to bring this library that was built by someone else, and it's going to have some functions. Instead of get, update, delete, like Axios, they're going to be called find by ID, and they do something. So you read through that to understand what they do. We're going to do this together on this project, and then you're going to do it by yourself in the afternoon. So here's the API, right? You run yarn server on npm run server. Now we know why, because the script that we have in the package.json is named server. That's the key. And then we have this user schema. What do I mean by schema? Well, schema is just the definition of the structure of the data that we're handling here. In this case, we're talking about users. So it's got a name, a bio, and then this stuff is going to default to the current day. So you don't have to pass that information. Same with the updated app. But the name and the bio, though, the name is going to be a string, and you have to pass it. It's required. And then the bio, Jane Doe, not Tarzan's wife, another Jane, is also a string. I believe this is a typo. I think this is also required. I think they both require. Okay? And then you're going to write a set of what we call endpoints. So that combination of the method and the URL is how you do the routing, right? So you can also say URI, right, for the identifier, or you could say, you're going to hear me use the term endpoint. So for me, /API/users is an endpoint. And you could hit that endpoint with a post or with a get. Same with a /API/user/ and then an ID that is a parameter. You remember those columns from React Router, right? When you pass dynamic parameters to the route, it's the same thing. You have something /API/user/ and you pass me an ID there. This is another endpoint. So we're basically building two endpoints that can handle different methods. Look how I can do to the same endpoint, two different methods, or to two different endpoints, the same method. A get to this endpoint, or a get to this other endpoint, or to the same /API/user, two different methods. Who handles this? Routing on Express. It knows what to do. And this is what I expect should happen when someone does a post to this URL. Okay? And these are some of the specifications, like, what happens if a client, any client, makes a post to /API/user? Well, if the request body is missing the name or the bio, hence they should say that is required. If that's missing, I want to stop the request right there. I don't want to go to the database or anything, and I just want to respond with an HTTP status code of 400. This means bad request. You might remember that from your Axios HTTP week. And then it's going to return this JSON object right there. Error message, please provide name and bio for the user. So if the information of the user is valid, meaning he's got a username and a password, if he's got the name of the bio and there are strings, or number is also string, you're going to return an HTTP status code of 201. That means created. And then you're going to return the newly created user document. This is going to require some thinking out of the box for you. Just know that it is okay to call that library that we have for the database more than once. Okay? So do a quick read on the stuff that you have available there and see if you can figure out how to do that. Okay? This is our job. If there's an error though, let's say that I'm trying to access that database and something happens, then we're gonna cancel the request again. We're not gonna do anything else. You're just gonna return an error. When I say cancel the request, I mean do not continue processing that request. Stop it right there as soon as you get the error. Or if you know that it's incomplete, it has no name or no bio, stop it right there and just return a response to the client. That's what I mean by cancel the request. So you're going to respond with a 500 error. This is the status code and this object as part of the data of the response. And of course, we have more descriptions for the rest, okay? And we have some stretch problems. We're not going to worry about those. This is just a mini. Questions about what we're about to start building together. So you're going to see me use this a lot, okay? I'm going to go to Slack a lot, and I'm going to ask you in a yes-no fashion. Let's see if it's already here. Now I'm asking if the packages were installed, and I call that dependencies. Then you clone the repository. Aha, so it's not, hasn't been used in this channel. Okay. Here we go. So for people watching the video, this is what that would look like. Something like this, where you answer yes with a thumb up and not with a thumb down. So since I had to install Poly, I guess this is not something that you're used to. So this is normally how I would like the class to go, right? This is my method, my methodology. I tend to write some code, introduce a concept, and I love it if you could be just paying attention to your screen. Don't worry about following along, because later I will either give you the time to complete the code or just copy and paste the code on Slack so that you can have it and catch up to me. So I will never expect that you're trying to type at the same time that I'm explaining something. So I'm not going to be typing and waiting for you to type, typing and waiting for you to type. I'm just going to go through the concept. I'll try to break it into smaller concepts so that you don't have a lot of things to remember at the same time. Break it up into small bites, and then I'm going to stop and do a yes, no to make sure that you catch up to me. So don't feel the fear that, oh, I have to type it, otherwise I'm not going to be able to complete the exercise. Okay? Now, the hardest part of this is resisting the temptation to follow along typing at the same time I am typing. It's really, really hard to do. But I really, really want to ask you that you do that. That you let me introduce the concept, and I will do my best to wait for you to catch up. Especially if you only have one monitor, like James said. Okay? So yes, no is a tool that I use a lot, just to make sure, am I ready to continue? If you are working on something and you're still typing, you're waiting for dependencies to download. Sometimes dependencies do the last 2 minutes to download. I'm okay. I will wait for you. Just say no there, and I know that I'm waiting for someone, okay? Cool. So I got yes from everybody. That means that everyone is in the same spot that I am. It doesn't work, but they have the code, okay? Cool. So I'm closing that, and I'm going to concentrate on this. There are some files in there. That db.js that I mentioned is right here. There's some basic code in there. It's not production code. It's just simple code. You don't have to touch that ever, right? We're just going to use it like we use an external library, only that this is something that's there for us, okay? We're not getting this from NPM. So we can close that. We don't need to touch it. We just need to know how to find it, right? Data DB. So the next thing is, if I am in index.js, if I want to bring this in, you would probably do this. This would be like kind of a default import. And you say import DB from since I am outside, I need to navigate into data/db.js, right? This is how you would do it. This is what is called ES6 modules, ES 2015 modules. Okay? Now, we're going to use a different syntax for this. Before there was imports on JavaScript, the Node team had something called CommonJS, like so. And this is the CommonJS module system. Why is this important? Well, because you are used to this syntax right here, but I'm going to switch this a little bit. I'm going to do nearly the same, but using a different syntax. I'm going to say constdb equals, instead of import, require. The same way. Okay? Like so. These two are similar. Nolan left us. Okay? This is how you bring in an external module. All right, so in order to build an Express API, I'm going to go through this, explain what it does, and then I'm going to have you run it, make sure that you can have something running, okay? So the first thing is we're going to use a library. It's called Express. So first step, we install it. Yarn add Express. Here we go. While this is going, we need to import it somewhere, right? So we're going to say, bring me in doesn't want to do it. Express equals require Express. Like so. Now that we have it, we can use it to build a server. So I'm going to say const server equals Express, and we invoke it as a function. This is how this library exports a function like jQuery, right? And we just invoke that, and that's going to give us a server object. Now we have a lot of convenience helpers on that server object, okay? And one of them is called listen. So I could say server that listen, passing it a port, and we're going to talk about port in a minute. Let's say 5,000, and then I could have an optional callback function. We're going to have one just to have a message on the console. So I'm going to say console.log server running. Okay, cool. So that's all the code I have. We're going to come back, and I'm going to give you time to continue. Let me just show you the demo fully, right? Let's go in here, and I'm going to type localhost 5,000. This is the port. So colon 5,000, like so. So the first one is, this is running on my computer, and the second one is on this particular port. Who doesn't know what that computer port means, what a port means? Do I need to explain that? Yes or no? Yes, all right. So a simple explanation of what a port is, I'm gonna show you register ports. You will see that from 0 to 1023, these are what is called well-known ports, and they're reserved for the system. You can't touch them. Now, from 1024 to 49,151, those are user or register ports, and then from that, they're dynamic private ports. So we can use any port within this range, right? What do we mean by register ports? Well, if you go and check a list of ports, oh, let me do this. Sorry. I'm gonna drop this on Slack for you, just in case you wanna have it as a bookmark. And then we're gonna do the same thing with this. Okay. You'll see that there are some well-known ports. Like for instance, everything on the web over HTTP without DS goes over port 80. By default, all the web servers, HTTP goes here. But if you are using HTTPS, which is an encrypted version of that, it would be over 443 down here. See what it says? HTTPS over TLS. And like that, if you go to port 25, that's probably your mail server there running on ports 25. Simple mail transfer protocol used for email between mail servers, and so on, okay? So that means if I go to localhost 5000 and I hit enter, I get this. This is telling me, hey, there's nothing running there. There's nothing. There's no server answering this. But let's see what happens when I run this server now. I'm going to say, how do I run it again? What command can I use? So my server is reading instead of running. Thank you. Yarn server, right? Why is it not yarn start though? Isn't it yarn start always that we do? Yeah, because the script that we have in package.json is called server, not start. Very nice, very nice. Okay, so this is saying that my server is running, not reading anymore. It's running on 5000. Let's see if that's true. If I refresh, oh, that's different. See? We're no longer saying, you know, it cannot be found. Now it's telling that it cannot get slash. And the reason for that is slash is the route by default means the root of the site. So if I do a slash or I don't, it's the same thing. For the browser is slash. That's the root, the first page on the site. Okay? So now we know that there is a difference. The server is actually there. It's just no one can handle what verb am I using? I'm using a get. So my browser by default always is going to do a get. And if I don't have any extra route in there, it's just going to do a read to the default route, to slash. So there's no one on my server listening to get requests to the slash route. This is the next problem that we need to solve. So how do ports work? Well, turns out if you think of a computer as a building has an address, okay? In the networking world, that's called an IP, Internet Protocol address on the web. It's just a set of numbers that identify a way to get to a computer. Each computer that is available on the web, on the internet, has a unique IP address for that server, for that physical server, okay? But here's the thing though, a physical server is not like a house. It is more, and we're gonna check the errors, don't worry, in a minute. It is more like a building that could have more than one apartment inside that building. So you need two pieces of information to find someone inside of that building. So if you want to visit the Smith family inside of a building, you need to have the way to get to the building, and then once you get there, you need to need what? The apartment number, right? So on that analogy, you could think of the IP or the domain name is a way to get to the server, and then the port is a way to know which application that is running on that server you want to access. Notice that when we saw the list of well-known ports, we saw 25 for a mail server. So I could be running a mail server and a web application here on port 80, and also my API on port 5000. More than one server running on the same physical computer. So this is why we can use ports. So those ports are like doors, right? That exist inside of your building, inside of your server. That's what a port is. Does that help? Kind of give you a context of what a port is. Cool. So we know we have a problem though. We need to handle a get to slash. So how do you do that? Well, we use routing, and here we start introducing routing. So after we create the server, not down here, but here, after we create the server, we can say, hey server, if anybody does a get to this particular URL, I want you to handle it by executing this piece of code. And what you have here is what I call a request handler or route handler, depending on who you ask. But a request handler is just a function that is going to take from 2 to, I think, 4 parameters. Those parameters are based on the position where they are, not the names. You could call it whatever you want. We tend to call it the homies, request and response. They always go together, so we call it the homies. The first parameter in this type of route request handler, type of middleware, is the request. So it's got information about the request. What information? Well, if you go to the Express website and you go into the API reference for version 4, which is the one that we're using, you will see that we have the Express function, the application, the request, and the response, and also this router uppercase R that we mentioned before to break up the application. So this request, if you click on it, you will see that there's some goodies in there. Methods like get, is, param, range, right? But you also have information as the way of properties. So the path, the protocol, the query, the route, secure, IP, the host name, parameters. All of those are there, available for you to use, okay? So in our case, we're calling this get method. And we're going to get this request object that has all of those, okay? Accept, get, but also there is a response. So I also have this response where I have things like append, attachment, cookie, JSON, send, end. And if you click on send, this is going to tell you an example of that. So let's try it out. Let's do that. Let's do this. Let's say, hey, when somebody comes to this, I'm going to do a res.send, and I'm going to start by sending just a string to the browser. Say, hello there. Okay. Save that. And look at my, this is set up, and we'll learn about all that later, but this is set up in such a way that whenever I make changes to my JavaScript file here, it restarts the server. So it restarted already. So I could go back and refresh on the browser, do a refresh, and now we get hello there as a string. And this is our first server. It can send back strings. What is HTML ultimately? Anybody know? Is it a number? Is it an object? What is HTML? HTML happens to be a string. So if I wrap this and I say this is going to be an H1, now I'm going to be sending back string of HTML instead, like so. Well, I need to close this like that. So if we do that and refresh, look at how this is now an H1. So I could send string, I could send data, I could send HTML. We saw this other method called JSON there. We're going to use that next. But first, let's give you a few minutes for you to go and copy this code, run the server, and see if you can get that message down there on the client. Your turn. As always, there's going to be a yes, no. Please answer no while you're working on it, and then come back and make it yes when you're done. This is pretty simple, but we're going to approach it in layers. We get this done, and then we introduce a new concept in a minute. Take your time. And I'm going to be looking at questions on the questions thread. Why do we use status JSON stuff? James, that's a good question. Hopefully it's going to get answered as we move on to talk about status and JSON. That's the next section. Looking ahead. Good job. Is there any good reason why we switch to 8,000 or to 5,000 from 8,000? Nope. Remember that anything between 1024 and a big port number is game. There's nothing special about this number at all. I wonder if we could do this instead. No, I don't have any good lead representation of the R at all. I was like, serve. So line 9 and 10 would be this and this. Okay, so what this says is, hey, server, if anybody does a GET request, remember, the browser by default is going to do a GET to this URL on my site, meaning the root of the site. I want you to execute this function right here. This is routing in action. This is saying, what is the URL and what is the method that you're using, the HTTP method, and based on those two, conditionally, it's gonna execute this piece of code. But then this function is gonna get passed information about the request, an object that represents the request, and one that represents the response that the server, things that we can do on the server, and then send a response back to the client. This response object has methods that we can use to do things like send some data back. So we're just calling on the response. We say, hey, on the response, send this to the client. Hello there. So whenever you get it, that's a good error. Yes, very good. Very good. So whenever you get an error that says something like cannot find module whatever, that means that we need to install it, right? Like in this case, if it says something like express, that's fine. It just means that this is an external library that is not built into Node, and we need to install it. So the solution for this is npm install express, for instance, if it was express, or yarn add express. You're good. It's just, this is an external package that we need to add it. So Ben, is this line and 10 making a little more sense now? Oh, wow. There's an error that says unknown encoding. I'd like to see the code, though. Remember that this is wrapped in a string. That's a good point. A regular string. Okay, let's take a look at this code real quick. Oh, but that says set encoding, not send, on line 9 on your code. Supposed to be send. That was your Visual Studio Code there helping you out complete that. Yeah, the autocorrect does that. You're gonna see me suffer from that a lot here. That happens to me a lot. It is helpful. Autocorrect is helpful a lot of the time, but sometimes, yeah. All right, let me see where we are. Are we ready to go? Yes, no, good to go. Let's see. Yeah, we're good to go. So let's take it up a notch, because actually we want to work with JSON, right? We don't want to work with HTML. We want to return some JSON object here. So let's change this. Let's see what happens if I do this instead. I'm going to have an object here with a message, or maybe it's just hello. WEB15. Okay. I haven't changed anything, just made this instead of a string, I made it an object. Let's see what Express is going to do with that. Okay, server running. Refresh. Look at that. This is actually, if we go and check this out, let me close this. Okay. If we check this out here and we refresh, you'll see that what we get back as the response of this is actually JSON. Look at that, double quotes and everything. A preview is going to show me the JSON object, right? But look at the response. It's an actual JSON object. Cool. So Express knows. Oh, by the way, I normally get this question, why is your JSON looking better on the browser? There's an extension called JSON View. JSON View Chrome extension. There are others. I just happen to use that. Here it is. Without it, it's just going to show a little different. It's just going to show you the string for the JSON. So I like to have it just because it reads better. Oh, yeah, Firefox really shows it better. But since we use Chrome because of the developer tools, Chrome doesn't do that as far as I know. So I've been using this for a while. So, okay, let's see where we are. Okay, but so far we're just sending some data here. We have this file called db, and if you go to read in the instructions, it says that if you call on the mini, if we call this find method, it's going to return a promise that is going to resolve to an array of users in the database. Let's go and try that. So first, if you haven't, go and require the database. So from index, go into the data folder, grab that db.js file there, like so, this line. And then we're going to use it in here. We're going to say, hey, const, and we might be tempted. Remember that this is going to return a promise, right? So we might be tempted to do something like users equals db.find, right? But we can't do that, really, right? Because it's a promise. So what we really need to do is db.find, and let's say, hey, then I should get some users. And when I do, I want to send those users back. Okay, so this is basically saying users equals users, right? I'm going to send those users. Catch, and these are called the bros. See, the same way that we have the homies, we have the bros, then and catch. They always go together. So if I have an error, we're going to send that error back. Save that. And this is the code. I'm going to test it, and then I'm going to let you go and do the same thing. Let's see if you get it to work. Okay, refresh. Ha ha ha! We have data coming from a database in our API now. The user's key with an array of objects. This is available since CSA. Your turn. See if you can return some JSON. Look at the 1137. I posted a link to it up there. Scroll up a little bit on James, on the messages, 11:37 a.m. Let me see if I still have it. Oh, okay, you got it. Cool. Is that true? Everybody's done and everybody sees data? If you don't say no there, I will continue. Is there any reason why I'm not just doing this? Nope, no reason at all. This will work. The thing is that if you do it that way, you're just gonna get an array of something, right? It's just an array, but you don't know what they are. So since I know that most of the time I just gave it a name. I just made it an object with the users collection there just to show whoever is getting it that these are users. That's all. But there's no other reason. So using send by default will always do that, right? It's gonna be smart enough to see what you're getting, and it's gonna, if it's an object or an array, it's gonna send that as JSON. If it's a string, it's not gonna do that. So I like to have it be explicit. I like to do this instead. So instead of using send, I do JSON. This is another method. Because having it be JSON on the other side has two things, right? One is the actual data that comes back, and the other one is there is a header, okay? On the client, remember those headers things? On the client, when the client is going from the client to the server, there is a accept header that passes some information about what are the different formats that I want to see as the client. This is the client communicating to the server. It's saying, hey, I would like this data to come back as, let's say, application JSON, or maybe application XML, which is another format for transmitting data that looks like HTML, okay? But from the server going back to the client, though, there is a header called content type. And this content type is going to use the same name, application.json, for instance. Or maybe something like text HTML. There are different values that are defined for this content type header. Now, on line 23, the client is telling the server, I would like to get JSON, please. And then on the 24, the server is sending back the data. Is saying, hey, what I sent you happens to be JSON, okay? Express handles all that for you. You don't have to worry about this. It's handled, right? But I could do something like this. I could send a string here saying data for users. And we know that this is a string. This is not JSON. This is not valid JSON, but I'm sending it as JSON. So when I refresh, this is what you get. You see those quotes in there? Let me show you that. If I change this to be send, Express now looks at this as, is this an object? Nope, it's just a string. Send back, refresh, look. See the difference? If you go look at the headers, though, it becomes even more clear. right? Let's do a refresh, click on localhost, look at the headers, and if you see the response header, the content type is text HTML. You see that? So the browser reads that and says, okay, he's sending me text HTML, so it's going to wrap that into the beginnings of the, if you look at the preview, it's just going to wrap it into HTML body, look at the response, and it's going to treat this as just a simple string. But by me on the server saying, hey, JSON, we send that, we refresh, and now the content type is application JSON. So I am telling the browser, even though what I'm sending you is a simple string, do your best to treat that as JSON. And this is what the browser does. Just wrap it in double quotes because it can't do anything else. It's like, okay, this is not a simple string. I'm just going to wrap it in quotes. But what's important is that when you're building APIs that are supposed to be a JSON API, I like always making it explicit here and using JSON. And that will always set that header for us automatically. It doesn't matter what the content is. Okay. So what about this? We have this 200, okay, that we're getting, but we're never setting that status code. What if I wanted to change that to be something else, like I'm a teapot? Remember that? I'm a teapot. Turns out that if we go check out the API documentation again, and look at the response, we have this status. Look at that. We can actually set the status code that we want to send to any HTTP status code. So let's do that. And we can use those, we could just chain those methods. And after this, I'm going to let you go and do it. So let's say that I want to return always with the joke of I'm a teapot. So I could say status is going to be 418. And then pass in the data. Save that. And now I have control. It's not always going to be 200. Now I have control of the status code that I want my server to respond with. One of the most important parts of an API is good documentation. But on the absence of good documentation, the next step that you should always strive, and this is not just for API, this is for your code in general, is you want to minimize surprises. And we already know that there are well-defined HTTP status code, and they have some semantic meaning to them. We know that 200 means everything was okay, and 300 is errors, not errors, but something related to things that moved, redirections, right? And then 400 means errors on the client, like you're sending me incomplete data, for instance, or you don't have access to that. And then 500 plus are errors on the server. So it is your responsibility when you're building APIs to return the correct HTTP status code. Again, we're giving you those as part of the exercise here. But when we start to not giving you the status code, we expect to see as part of your MVP that you take that into account and that you always return a correct status code depending on what happened with the operation the client is trying to do on your server. Okay? It is expected of you to return the correct HTTP status code. So why does the data get returned? Because by default, Express is just going to default this value to 200. So this is what is happening under the scenes. It's always returning 200 if you don't provide one. But if you see, even if when it wasn't there, we were getting this 200 okay. So there's always a status code in there. Express is doing that for us. We're just changing it manually now to be I'm a teapot. So if we save that and go and refresh the server, nothing changed, just a status code. And then localhost is now saying, I'm a teapot instead. Notice that the data is not affected by that, right? It's just a status code. It's just the way that the client sees this. Why is this important? Well, because the clients are going to make decisions based on that. When you do an Axios, you do then and catch. That catch is going to can see the status code. It's not straightforward, really simple to do, but this is on the case of Axios. There are other libraries, like if you're doing Angular, the HTTP on AngularJS, which is another way of building front-end applications. They have their own HTTP library, and that is going to make it. It's going to make a difference there. It says if it's an error within the 400, I'm just going to call the catch and I'm going to throw an error. Okay. So the client can look at the code and make a decision on what to do. For instance, there is a difference between 401 and 403. 401 says, I don't know who you are. You need to tell me who you are. You're not authenticated. 403 says, I know who you are. I don't care. You have no access. So it's the difference between who are you and you don't have access to this, even though I know who you are, right? So it's important that the HTTP makes that difference. So the client could say either, hey, you need to authenticate in order to do this, or I'm talking about the client now. On your React application, you could show a message to the user that says, you don't have access to this resource. Talk to the administrators. Cool? Takeaway, you should always return the correct status code. In this case, would be 200. So let's do one more, and then I'm gonna probably give you the code. What if I want to do something like this? What if I wanted to say let's do /API /users, and then pass an ID like 2. We should be getting Geekbot right here, right? So if I do that, it's telling me, I don't have anybody handling that. So let's see, and we're getting a 404 from the server, not found. That's correct. So let's go and do this. Say, hey, how can I handle that? It would be a GET request to /API /users with a dynamic ID. I want to be able to pass 1 or 2 or 3 there. Any ideas? It's definitely a GET. So we're going to say GET route. It's definitely a GET. Now, what is the URL that I want to watch for? Connections? Look at it right here. What is the URL there? So /API /users / and then a dynamic ID. So it would be to /API /users. Let's close this because we don't need it for now. And then a dynamic ID like so. Okay. And now, but how do I get access to this? And again, this is introduction to routing, right? So now I need a way to read the URL parameters. If I was building this, I would say, okay, this is part of the request. And this is the parameters of the request. So, I don't know, const.id equals rec.params.id. Yeah, Jonathan, exactly that, right? So as part of the request, I have information about the parameters too, not only the URL. So I could say rec.params, and this is going to be an object that has all of the parameters on the URL, including this ID. This is the name. If I change this here to user ID, then the key in the params object would be user ID. Okay? Like so. So now I have the ID. And I know that if I go read the documentation on the little library there, the little DB file, I know there is a find by ID in there. Remember that? Find by ID, right there. Expects an ID and it returns the user. So let's try that. Let's say, hey, DB, found by ID using this ID that we got from the URL. then uncatch the browse. If I get an error, I'm gonna send it back. And this would be a 500 for now, because we don't know what the error is, but it's something that happens on the server, has nothing to do with the client. And then we're going to JSON the error there. Of course, you handle this in a better way, right? The whole idea here is we want to do it fast, and I'm just sending this during development. What really happens in reality is you start seeing what the errors are, and then you send a different message depending on the error, okay? If this succeeds, I should get a user. Maybe. And the reason I say maybe is it says, returns the user corresponding to the ID provider or an empty array if a user with that ID is not found. So if I find it is a user, if I don't, it's just an empty array, okay? That's what it says. I don't know whether it's the truth or not. We'll try it. So let's assume that I probably have it. So I'm gonna say res.status, everything went fine, 200, being explicit there, and then JSON sending back the user. Save that, and now we have another endpoint where I could check and ask for a user with a particular ID. Okay, let's try it out, and then I'm gonna let you go and build it. So /users2, if I hit that, I get a Toki bot, the Git bot. If I pass 1, we get that. And if I pass, let's say 4, nothing. Right? There's no user with that information. 2, 1. I see that the API is not doing what it's supposed to be doing, though. It's supposed to be sending an empty array. Okay? Nothing. Bug on the API, on the database access layer. Right? So as long as we have a valid ID, so that means that I could definitely now, I'm gonna do one more thing, and then I'm gonna just give you the code, okay? Because this is not, you're just gonna be typing it. So I could say if I have a user, then I'm gonna do this. But if I don't have a user, then I'm gonna say res.status. What would be a good status to say didn't find it? "404", correct. And then send probably maybe something that says message, user not found. Save that, and let's go try it out. So what I expect is if I do 2, it's there, but if I do 4, it's not there, and it just gives me that message that says the user is not found with a 404 here on the right. And then let me go to the questions. And we're gonna call it a day there. Okay, so it says here, the syntax for JSON is being deprecated. If it is, as soon as it's deprecated, I'll stop using it and just use send or whatever is next. Oh, he means that the one passing the status code and then the data in the same thing. I never use that syntax actually. I'll always define the status this way. So if it is deprecated, it's not going to affect none of the repositories here. We don't use that syntax. Good job, Max. I didn't know that. Okay, so I have questions outside of the questions thread. So let me see, questions, nothing on there. So let's go to the regular thread. Hopefully I don't miss anybody. There's something related to rec.params. So getting blank for 1 and 2. So why do we use rect.params.id? Is that something we were taught before? Kind of forget. Okay, so quick review. Maybe that answers some of those questions. We're doing a couple of things here. The first one is we're grabbing from the URL parameters this parameter right here. If you call user's ID, then you're going to be grabbing the ID. As a way to show this differently, it's like, why am I using ID? Well, because I'm grabbing this parameter user ID and I'm saving it in this constant right here. This is why I use ID instead of user ID. Okay? Because I grab the user ID from the params object provided by Express. Express is going to look at the URL and grab that and give me that nice object. You can use it. But I am saving it as ID inside of this constant. And then this is what I'm using. So if you cannot get, you have to make sure that your server is running, that you don't have any errors on your server, so it's running correctly on the terminal, that you have the correct URL defined here with a slash at the beginning is important. Sometimes we forget to have that beginning slash. So if I do API users, then that's not going to work. So it's going to have that slash in the beginning, slash API slash users, if you're using mine. If you don't want to use the API, just use slash users. This is the URL you're going to be visiting on the browser, slash API, slash users, slash, and then passing an ID. Hopefully some of those will fix it. So as promised, I'm going to drop this on Slack. This is index.js. How I have it right now, because I want you to try to see if you can run it. This is some sample code for you. And let me know if it runs. So what this right here is doing, right? The params object is going to be an object and it's going to use the same name that we give this. So colon whatever, this is the name of the property of that request a params object. First day always goes over time a little bit. So does this have any significance? Nope. You can define the name that you want here in this parameter. Just know that when you read it from the rect.params object, it's going to have the exact same name here, including the casing. So I could call this user. Only that I would not have to read it as user here, or ID. And then I read it as ID, right? They just have to match, or they will match. So what's your job for today? Okay. You have the lab project that's on training kit. Still gonna drop it here just so that it's there already. You're gonna take a break first, and then when you come back after lunch, you're gonna work on this project. It's gonna be fairly similar to what you've seen so far, right? You got a library, read through the code, because this might be different in some of those methods, okay? It's not gonna be one-to-one, 100% with what you have in the mini. A little challenge to have you read the documentation. Okay, so you read this to see what to expect when you call those functions from the DB file. And then, of course, you're gonna deal with posts instead of users, right? So you're gonna have a title and a content. They both require. And you're gonna start working on these endpoints. Even though it used to say 2 days there, but the part-time class does this over 4 days, I think. So we removed the 2-day note. You're gonna work on this today and tomorrow. So this is due complete at the end of tomorrow, not today. Today, you have learned how to do a get and a get by ID and how to wire up the server. So today, we expect that you get to the get and the get by ID. Okay, so you're gonna do that get and this other get right here. The rest, you don't expect to finish the rest until tomorrow. You work on those 2 and you're good. You're MVP today. And then tomorrow, you work on the other 3 as we learn how to do them. I did refresh the page when I changed. I mean, after that change? No, I haven't. If I do number 2, then I get the data. Okay. And of course, you have the specifications here. What do I mean by I want you to check for this? Well, we did a quick check there, only that instead of doing it on the params, you're gonna learn about the pose and how to check for the stuff in the body tomorrow. So concentrate, of course, on the stuff that you've seen today. So the get to posts. If there's an error, you return 500, same as the example. If you have the idea, if you don't found it, you didn't found it on the get by ID, then you return a 404 like the example. If you do find it, just return the data, okay? If there's an error, it's gonna be 500. Tomorrow, we'll do the others. Questions on the assignment? So the get and the get by ID, have it ready this afternoon for your PMs. Tomorrow, the rest. 2 days for this project. So Andrew didn't work, but now it works. So cool, perfect. All right, that's it. So hope this is feeling better now, working on the server. And we'll continue mañana. We'll continue mañana. And we continue over the next 4 weeks to continue to work on the back end. So it's gonna get more familiar as you do it a few more times. So see you tomorrow, today on Slack. Bye-bye.